many companies are on a journey evolving their monoliths to microservices or even managed microservices. And I'll say many companies, but it's not always just you can't really think of a single company as on this journey. You have a lot of different departments, a lot of different projects, and each of them are kind of in a different place on that journey. Some projects, some companies started from someplace different. Maybe they started from a service-oriented architecture, which is sort of a half step along the way towards microservices. In microservices architectural pattern, as you all know, an application is composed of finer-grained services that intercommunicate via these lightweight, simple mechanisms that are called APIs. The goals of this: increase product velocity, manage complexity of code, perhaps polyglot service construction where you've got multiple languages, different languages being used to implement different services and working together, and empowering developers in order to advance business goals more rapidly. So that's all familiar to you. There is an alternative, of course, to migrating a monolith and decomposing it into a set of microservices, and that is just wrap it. Just wrap it in a service or in an API and call into that directly, just kind of freeze dry it that way and get access to it. Either way, it's a service, it's just a coarser grained service, and you don't need to touch things as much. In fact, in the keynote yesterday, we saw Jennifer Lin describing this exact scenario with one of the tools that works with Anthos, where you can take a VM where you've got a system already running, run this tool, and it pulls it into a container and makes it hostable in Kubernetes engine, regardless of where you want to run it. So you kind of wrap it, maybe one step along the path of the strangler pattern, if you're familiar with that. Wrap that monolith and put it wherever you want in that container. So a couple of different options. Neither are wrong. Many companies have different projects that are traversing this path in different directions. The key thing to remember is APIs are the communication contracts. So between the services that are intercooperating, APIs are the things that allow those things to communicate. Between clumps of services or clusters of services, maybe you've got them structured in different meshes, more or less formally managed, APIs are used. And again, between clients that are external to your network, to your meshes, it's APIs. So APIs are the interface, not the implementation. APIs are the things that allow parties to interchange information. Some of these APIs may be, really common structure for APIs is HTTP1 and REST, and maybe you're going to use JSON for your data format. That is not presupposed by the rest of what we're going to talk about here. That's a common one, but that's not the only one. An API is just a programmatic way to access the system. So we see a lot of people using HTTP2 now, we see people using gRPC, we see people using GraphQL, and lots of other options as well. So API is just the communication mechanism. So I want to take a moment to break down service mesh infrastructure and look at what we want out of that. And to do that, I want to just take a step back and start from the basics. Now, some of you may be familiar with Istio. Maybe some of you are running Istio. Istio is 1.1 is in production. We've got some CVEs even that were updated. So you've kind of updated some vulnerabilities that were discovered recently. Maybe you're further along the path, but maybe I suspect that a lot of you are looking at Istio, are examining services mesh infrastructure, are kind of building your own services mesh infrastructure with different proxies. Maybe you're using Nginx, maybe you're using HA proxy, maybe you're using Linkerd, maybe you're using Envoy at its base. And you're less familiar with all of what's going on in Istio or in service mesh in general. So let's kind of take a step back and just look at that. So the first thing is services intercommunicate. So we have a bunch of them in the constellation intercommunicating. We're just going to look at two just for the purposes of illustration here. And we've got that API that's connecting these two. Once we have disconnection or decomposition of the monolith into multiple different services, things that we had some assumptions about before, which is, for example, connection between different modules is going to be in process and secure. Those assumptions are no longer accurate, right? No longer applicable. Now, the different modules are services, are realized as services, and there is remote communication between them, so we need to secure that. So if you're going to go into microservices, one of the very first things that you want to be able to do is have mutual TLS so that both peers in the exchange can authenticate each other, and you can perform authorization decisions at the service level based on the identity that's been asserted with the TLS certificate. So this is all just kind of basic stuff, but it's kind of hard to do when you have just two services, no problem. You can issue certs, they can compare them, you can make sure this is the peer that I expect, and everything's good. As you add a number of services, that starts to get a little more complicated. But for sure, you're going to want that. Ideally, you want to provision certs automatically. So remember, keep in your mind, we're looking at just two, but there's a constellation of these things. There's 15, there's 20 different cooperating services, and I want to provision certs for all of them, and I want them to be distinct. It's cheating. I know there's some of you out there. It's cheating to use the same cert for every service. You can't do that. That's not the way it's going to work. It's not going to work well. So you need different certs for each service, and you'd like to have policies in place as well for these intercooperating services. What used to be really easy, just call the module. It's an in-process call. It's a method call. I'm calling to a different object. What used to be super easy is now kind of maybe a little bit iffy. There's a network there. The network is not always present. The instance is not always there. So you need policies like, am I going to retry this call? If I am going to retry, how many times? What's the back-off interval? What's the timeout? At what point does the client, the initiator of the call, say, this has failed. I'm going to declare this call failed and maybe retry or maybe just give up. How do I do circuit breaker? So if I continue to try to hit the same instance and that thing is just not giving me satisfactory response, maybe it's no connection at all, but maybe it's just an error, I'd like to kind of take that out of rotation and not connect to that instance anymore. If I'm doing services mesh, right, I've got multiple instances, so I've got a different set of, I can connect to different ones, but let me just take that one out, just flip that circuit breaker and pull it out. I want to be able to do routing based on maybe content or identity, time of day, authorization. So all of those things are sort of policies, and there may be more. And you kind of want to implement all of those in the disparate services. And remember, each of these services, we may be talking about a polyglot environment. So while I am decomposing, let's say I've got a Java app or I've got a .NET app, and I'm decomposing the Java code or the C# code into multiple different services, then I can say, okay, it's all one language. Super easy. But we all know that that's not how it works in practice. Yes, you're going to decompose an existing system, but then there's a new team that's coming up and they want to use a different language. They've got this Ruby module that does just the right thing. They've got Python that they want to try. They're much more productive with that. You're using Node.js. So you can't have all of these provisions, all these policies implemented in all those different languages in the same way, in a compatible way. So the thinking here is that rather than build a library for each one of those languages and platforms, for Java, for C#, for Python, and so on, let's factor out all that capability, all that smarts, the policy enforcement, as I talked about, the mTLS management, the session management. Maybe I've got requirements for the particular algorithms that are used in the TLS connection. Let's factor that out and put it in a proxy. And it's one proxy that works with everybody. And we'll call it a sidecar proxy. So this is the model that works in a scalable fashion for services mesh infrastructure. And in fact, this is the Istio model. This is the model that Istio uses. It uses that sidecar proxy. It's actually implemented by a separate open source project called Envoy. All of that stuff, the TLS management, the policy enforcement, all of that is done by Envoy. And your service, you can implement that in Java, .NET, Node.js. It connects only to the outside world, either with inbound or outbound communication via that proxy, via that sidecar proxy. This is how Istio works. And Istio adds that control plane that you see depicted in the bottom here with a couple of different modules that you can read about in the Istio documentation. This isn't a deep dive into Istio, but just kind of an overview that allows certificates, for example, to be provisioned for each instance, for each type of service in your mesh, and authorization rules to be provisioned centrally and then sent out to the proxy so that they can enforce. If I'm service B, I'm going to allow only service A to call me. I'm not going to allow service C to call me, or any other new service that gets introduced into the mesh, if you choose to restrict it that way. So those are the kinds of things that the control plane for Istio do in this mechanism. You'll see those two different diagrams, data flow and control metrics flow. The high throughput, low latency calls, the things that are kind of running your business, are all happening in the data plane. One service talking to the other, lots of services kind of connecting together. You have this mesh of services all intercooperating at very high speed. That's all happening in the data plane. The control plane is just separate. It does not get invoked for every communication, for every request. Most of that is cached. If you want to make a change, you make it in the control plane, and then it gets provisioned. The proxies get updated, and they behave according to your configuration on the next go-around. So Istio also adds some other things you're probably going to want as a service mesh, and that is an ingress gateway. So now I've got this mesh, and I'm managing all the communications between. I've got TLS security, so I'm encrypting all the point-to-point communications. I've got policy enforcement. I'm retrying the way I want. I've got back-off intervals. I've got circuit breakers. But I also want to admit inbound communications to that controlled mesh, to the thing that I'm managing nicely. I want to have an ingress gateway. So Istio adds this as well, adds this concept. And what it allows is an internal client, some other client application that's not part of the mesh, to send in requests. And again, you can have policies there too that allow, you can say it needs to bear a JWT, it needs to bear a JOT, and it has to have this kind of issuer, or it needs to have TLS, or it needs to have mutual TLS, and the TLS CN has to be such and such. So you can do all that with the ingress gateway as well. Likewise, you're going to want to be able to control communication that initiated from inside the services mesh and sent outside. In many environments, you just don't care about that. You've got network firewall rules running somewhere, but in some, you want to be even more careful about that, and you may want to do some routing decisions. So there's a way to manage outbound communications as well. And this is what we would call a managed mesh of services, or a service mesh. Some people say, and I want to be particular about the definition of the term service mesh. Some people think of service mesh as, Istio is a service mesh. And there may be other tools that are out there, other pieces of infrastructure that are out there that you call a service mesh. The way I think about it is, a service mesh is a mesh of services. It's just a bunch of services that are intercooperating and intercommunicating. Service mesh infrastructure is what allows you to manage all that. So that's just my kind of phrasing, but you'll hear people throughout the conference say Istio is a service mesh. To me, that feels just a little bit inaccurate, but I get what they're saying. In the rest of this talk, we'll be talking about service mesh infrastructure, and Istio is a good example of that. Okay, so just to so that's kind of a brief, quick overview of service mesh, and this is why you would want to use a service mesh. It's connecting, securing, controlling, and observing the services in that mesh. Next thing I want to talk about is API management, and it's management for shared APIs. So shared APIs may be wrapped around legacy systems, monoliths, and what we want to be able to do is allow external clients to call into those systems. Why you use management? First, discovery, so an external developer. We want to allow those external developers to see what APIs are available and then provision credentials for use by that developer in the apps they build in order to make calls into the API gateway. We want to modernize systems, we want to report, and we potentially want to monetize APIs. On modernization specifically, we'll talk about a couple of different scenarios here. Maybe you've got a SOAP backend, maybe you've got an XML backend, you want to kind of make it look like JSON, or maybe you want to add caching, you may want to add routing. And modernization actually helps, this aspect helps a lot when you're breaking down the monolith, as we'll see a little bit later. You can add routing right in that API gateway layer, pointing some calls to the existing monolith and some to the new microservices. So this is what it might look like as an evolution of combining services mesh with API management and API gateway. So we've got our API gateway, external clients calling through there, internal clients calling the systems that exist, and we start to introduce some microservices. Maybe we're on that journey, decomposing the monolith into different microservices, and then maybe we're adding a few services. It's not just decomposing, but it's adding a few things. It's augmenting, we're modernizing and adding and extending. And so now the internal app is going to be calling into the existing monolith, the new services, and the API gateway can kind of direct and route calls in as we see fit. We start to see proliferation though, and this is when you're really going to benefit from that services mesh infrastructure, something like Istio, and that's when you can create these clusters. Use these clusters of services and establish those policies and all the things that I talked about in the beginning of this session. You can have multiple different clusters, obviously. They can run in the same Kubernetes cluster or different. You can run across clouds, and Greg will actually show you a little bit of multi-cluster scenarios. This is what we think of as the kind of clean model that composes API management and service mesh management or service mesh infrastructure in an environment. So this is the clean picture, super easy. A person came up to me and said, look, I have a question about maybe internal clients. Do internal clients, if they want to connect to my system, do they have to go out and into the API gateway just to get into the system? And the answer to that is no. We already talked about the ingress gateway that's part of Istio, and you're going to have that with any service mesh infrastructure. So internal clients can continue to use those kinds of approaches, but external clients, for reasons we'll get into, will probably want to use something maybe a little more structured in order to manage that communication there. This is the mental model that I like to offer people when they're thinking about how services and APIs work in an enterprise. So at the base level, you have your infrastructure. That's going to be your platform as a service, your VMs. Maybe it's Kubernetes that you've chosen. Maybe it's a composite of those things. You've got different projects and different people are using Cloud Foundry, and who knows? You've got a bunch of different infrastructure. On top of that, in some way, you're building services. And what we like to say is there's going to be thousands of those, depending on the size of your company, and you want to manage those. You want to wrap services management around those. Now, not all services are going to be managed. It's an aspirational goal to have all of them managed. Exposed by those services are APIs, and in the same way we aspire to have the thousands of services be under management, we aspire to have the APIs that get shared out of those services. Not the ones that they're using to intercommunicate within the mesh, but the ones that get shared out, we aspire to have those under management too. Not all of them will be. There are some pitfalls associated to not managing your APIs, and Greg and I can both attest to that, but that's the aspiration. So that's the model. Platform, thousands of services, hundreds of those may be exposing shared APIs that get consumed by clients that are either inside the company but distant from the teams that are producing, or outside of the company, some external client. And that's the mental model. Now, with that, I'm going to hand it over to Greg, and he's going to kind of make this real for us with a demonstration.
Awesome. Thank you, Dino. All right. So I'm going to go through this pretty quick in the interest of time, but I want to set up with a little bit of background in terms of what you're going to see in the demonstration. Of course, we're going to use the proverbial ACME company. What haven't they done? They're a pretty typical enterprise. They've got different departments, divisions, locations. Today we're going to concentrate on two teams. We're going to concentrate on the product team, manage things like products, product catalog, and the logistics team. They manage the warehouse, delivery, those sorts of things. Now, ACME's feeling a lot of pressure from startups, kind of trying to disrupt the market, and the business has asked IT to move faster. So both the product team and the logistics team took a look and they said, you know what, maybe if we modernize a couple of these existing monoliths, we can move faster. And they made some decisions. They chose to go with a Kubernetes-based system using service mesh infrastructure and API management. The product team has three services that we're looking at here. They have their product service and then a location and a pricing service. The main consumer of the product service is a mobile app. It's an internally developed mobile app. You'll notice in this case that mobile app is actually going through an external API gateway, in this case the Apigee API gateway, that happens to be running as SaaS in the cloud. The logistics team has an inventory service. They also have a third party that accesses that inventory service that helps them and needs accurate inventory counts. So with that, let's get started with the demo. Can we go to the demo, please? All right. So we talked about the product team. That's where we're going to start. They are using Kubernetes, and they made what is the obvious choice for where to run Kubernetes, which is GKE. So they've got a few different clusters here. The cluster that we're going to worry about today is this dual cluster 1. It's a 4-node cluster. And let's just take a look and see what they've actually got running in there. So you'll see, just like what we would expect to see, we've got a product service, a pricing service, and a location service. Those are the pods that are running in this cluster. So at first, they kind of built these services, and everything was great. And then they had the operations team, the security team come along and started asking questions about, hey, which service communicates with which, how do I view the logs, all of that stuff. So they decided that, they're developers, they could develop libraries and build all this stuff into their services, but they didn't want to do that. So they chose to use Istio as their service mesh infrastructure to handle all those things for them. So let's just take a look and see what they've got running from an Istio perspective in here. And you'll forgive me, I'm just going to copy all my commands because otherwise you'll see lots of ID10T errors as I try to type in. And if you don't know what ID10T is, you can type that into your phone and figure out what that is. So you'll see here there's a bunch of pods running for Istio that enable the service mesh. You'll see things like Citadel and Pilot that you also saw up on Dino's diagrams up there. And so now what I actually want to do is I'm going to go on a small tangent very briefly. So previously in my career, I worked for a logistics company. And one of the things I was responsible for was handling all external communications with third parties, customers, what have you. Now, occasionally, we'd have to set up a mutual TLS connection with one of these third parties. And that was pretty much always my option of last resort. I hated it. And it usually went something like this. So we'd get on a call, and sometimes I'd have to explain to them why I wouldn't create a private cert for them. And then we'd exchange certs, and I'd load the key on my side, and they'd send something in. And they'd say, it's not working, and I say, well, you sent me Y, but I see you're actually sending me X when you send it, and they'll say, no, we're sending Y, there's no way we're sending X, and that would go on from anywhere between an hour to 2 weeks. So now I want to enable that same feature within Istio for our different components. Just a little bit of setup here. I've got another container that is sitting in a namespace that is not Istio injection enabled. So I'm going to connect into that container just to show you how it calls the pricing service. All right, I'm in that container, and I'm going to make a call to our pricing service. And you'll see, actually, it worked, right? So that's interesting. This isn't participating in the mesh, but it worked. Well, right now we're in what we call permissive mTLS state. And what that is as you're first bringing services into your service mesh, you may have services that are outside that can't communicate with that. And so anything that's in the service mesh is automatically going to establish an mTLS connection, but anything outside can continue to connect any way that it did before. All right, so with that, I actually do want to change this to strict now, and I'm going to show some YAML. There's only 2 times that I show YAML. I'm sure if you guys have been to sessions here, you've seen lots of YAML probably so far in this conference. I have just a couple of very simple YAMLs that I'm going to show. So this is the rule if I want to make it strict mTLS. And basically all this is saying is that for the pricing service, I want to set the mTLS mode to strict. So let's go ahead and apply that. Yes, maybe. Is that a little better? Yeah. Okay, so we applied that. Let's go back into our container. And let's attempt to access that service again. As you see, did not work. So I'll tell you, honestly, every time I do this, it brings me joy. I didn't have to create a certificate. I didn't have to set it up. I didn't have to negotiate with anyone. It just worked. That alone is like worth the price of entry into Istio and service mesh infrastructure. Okay, but let's change pace here for a second. We talked about the fact that the main consumer of this product service was the mobile app. So how does the mobile app obviously isn't participating in the service mesh, so how does it get access to these things? Well, that's where API management comes into play. And what you're looking at here is a developer portal built using Apigee technology. This is just the landing page. I'm going to kind of get into this pretty quickly. So I want to see what APIs are available. You'll see there's a product API and a product catalog API and inventory API. So let me click into the product catalog API. There's some documentation here. So just briefly, all of this documentation is being built off an Open API spec, version 3. That Open API spec is actually hosted in the Apigee spec editor. So that's just kind of how this is happening in the background. So I want to actually give this a try. I'm the mobile app developer now. I want to give it a try, but I see that there's some sort of authentication required. So let's see, how do I actually do that? So I'm just going to go to the quick start. You see, okay, I see I've got to sign in, register some apps. I know that already, so I've done that. I've created an account, and I've created some apps. I'm just going to click into this first app here. See a couple of pieces of information. There are some API keys, and then there's a couple of products that I can choose from. At this point, I need to back up just a second because I've introduced a couple of important concepts here from an API management perspective. One, developer. This is our API consumer, right? So this is the audience of this developer portal. So I created a developer account. A developer wants to have access to APIs, so a developer creates an app. And an app is what provides that developer access. When they create an app, they will see different products that they can select. Now, what's a product, and why do we call it a product? So a product is nothing more than a collection of APIs, maybe sub-resources within an API, maybe just one API. And basically, it's the way within Apigee's API management to select what the app is allowed to actually access. And why do we call it a product? Well, we've found that companies that are the most successful with their API programs, they treat their APIs like products. What does that mean? They have a product manager. They use outside-in thinking. So they develop their APIs with the API consumer in mind. They don't just say, hey, I've got a system, it's got 6 fields, I'm going to expose those 6 fields, and that's my API. So just some important concepts and in terms of API management. So I want to actually execute that. I'm going to copy my key. I'm going to go back over to the API. I want to just execute this product here. I want to authorize this. Click here. I want to enter my key. Oh, wait, I don't even have to enter my key. Since I'm logged in, it knows who I am. It knows what apps I have. I'm just going to select that app. I'll click authorize, and then go ahead and execute. And you'll see that I get a response back from the product service. So right within the developer portal, the developer can try it out. Now I want to make a point here, and this is that the mobile team never talked to the product service team. They didn't have to figure out how to do this. They came here. It was completely self-service. The product team didn't have to be involved at all in allowing them to access this API. So that's API management. All right, so let's try to go ahead and access that without an API key through the app just to prove that indeed it is going to fail. Oops. I got to get out of that container. All right, so failed to resolve the API key. No surprise there. Let's go ahead and do that with the API key. And I'm sorry, my font's going to get smaller here because I've got a bunch of different screens. But nonetheless, you'll see that it got a response. And then what I wanted to show here in the upper right-hand corner, this is the product service. So you see we lit up the product service. And then the product service actually called the pricing service as well. One more thing I kind of want to show here. And that is what happens if I grab a specific product. So I'm going to come back over to my shell here. So you'll see here, again, we lit up the product service, we lit up the pricing service, and in this case, we lit up the location service as well. So these are all running in the mesh. They're all protected by mTLS, and that kind of covers the product team. So I'm going to move quickly over to the inventory. And so let's see here. Let's take a look at what these guys have. So the inventory team, again, same thing. They're running on GKE. They have their very own project, their very own cluster, their very own mesh. We're going to go ahead and connect into that one now. So I'm just going to copy the command to set my credentials. Go ahead and execute that. Create some space for us over here. And then I want to take a look at the logs for the inventory service. Just give it a second. And you'll see that indeed we had a hit over to the inventory service here as well. So let's go over here. So what does that mean? Well, it means that the product service called over to the inventory service, right? And we know that there is external access to this as well. So let's just try to go ahead and access this same guy from outside and see what happens. So if we go there, we see, oh, it's permissions denied. The Apigee Istio adapter, in this case, denied that, and it's looking for an API key. So wait a second, what does that mean? How did the product service call into the inventory service? Well, the way these meshes are set up, they're actually a dual control plane setup. What does that mean? It means you've got 2 separate Istio meshes, but they're essentially acting as one mesh. And the way that that's done is through some magic with the core DNS, as well as sharing a root certificate authority. And what we essentially do is we create a service entry that advertises the services that we're going to be calling. And I'm going to go ahead and show you what that looks like here. And this service entry, in this case, is actually going to be deployed in the product cluster because they're calling out to the inventory cluster. So just two things I want to point out in this little YAML. So one is the host. So it's inventory service.default, which is the namespace, .global, which is saying, hey, this isn't in my local mesh. I need to go look somewhere else for this. And then I'm going to point out this endpoint address here. That's actually the ingress gateway. So you remember Dino talked about the ingress gateway. That's actually the ingress gateway to the logistics team's mesh where the inventory service is running. So it's just that simple. It calls over there. Mutual TLS works across these meshes just the way it does within an individual mesh. So now that said, let's go ahead and grab a curl with a key here, just to show that indeed you can also access this from outside the mesh. And indeed, so we called with the API key, and you'll see we got a product ID and a quantity back from the inventory service. So my point that I want to make with that is it's getting the full benefits of API management. That third party could go into the developer portal, just like we saw for the mobile app, get their key, all of those things, but it's calling in, it's not coming through the SaaS gateway. In this case, it's going directly to the mesh, and the Apigee Istio adapter is verifying that key, as well as sending analytics back to Apigee to report upon, to the gateway itself. So with that, it almost wraps up the demo. There's just one other thing that I want to talk about briefly, and that is the product team, as they were going through, they're actually modernizing, and they had an existing service that was serving up the product catalog. It was actually a fairly modern service. It was RESTful in nature, but they wanted to change the API. They made some breaking changes to the API as they were modernizing. So the first thing they did is they used the Apigee gateway, and they actually used that to mediate and expose that API in the new version to some new customers that wanted to come in and use that in that way. So that was the first thing they did before they actually built the service. And then they started to build this new service in the service mesh here. And they used the Apigee gateway to actually help with the migration process. And one of the ways that they do that is they've got, basically based on the client that's calling in, they can set up and say, hey, a % is going to go to either the old service or the new service, and they can slowly roll to the new service that way. So the app that I've been using so far has been set to 100% the new service, but I actually have another key that calls, it's set to 50-50. So it's doing a bit of math. It's not always exactly 50-50. It's random in nature. But we'll go ahead and try to call this a couple of times. In this case, it looks like it's going to be exactly 50-50. So you see my first response there. That was the modern service. We've dummied it up a little bit here for the demo. It's got a smaller response block, and it's a little faster. The second one is actually going to the legacy service. It's got a bigger response block, just so you see that. Now, if we could switch back to the slides, please. All right, so just a very quick recap, I went through that pretty quickly. So mobile app calling through the API gateway to get to the product service. That product service is living inside of a service mesh. That service mesh, that product service, is actually calling out to another service in a completely separate service mesh, but through the dual control plane setup, it's actually acting as one service mesh. And then there's a third party that, again, calls to that inventory service, but it doesn't go through the gateway. It uses the Apigee Istio adapter. With that, I'm going to call Dino back up on stage because I've got some questions for him. So my first question is, when do I need service mesh infrastructure?
So my opinion on this is anytime you have a significant number of cooperating microservices, get a service mesh infrastructure in place because you want that mTLS. I thought you were going to throw this to me.
I was thinking about it. I was going to throw it at you.
A little scared there for a minute. You want that mutual TLS. You want to be able to secure the communications between the two peers or many, many different peers, and that becomes really important. And if you get Istio, then you get a bunch of other things for free, the observability, the aggregated logs, and some other things.
Okay, well, that's fine, but my consumers, they need a response pretty quickly. What about latency?
It's magic. There is no additional latency.
Oh, that's awesome. You heard it here first, folks. No additional latency.
No, actually, okay, so let me just correct that just a little bit. Just a little adjustment. There is a little bit of latency, small, but you're not gonna notice it. It's so small, invisible.
Invisible.
No, seriously, there will be some latency. There's an extra hop. There's a proxy there. You guys all saw it in the picture. So there's going to be a hop there, but it's a sidecar. So that proxy resides in the same pod with the service. So the hop to the proxy is going to be relatively quick. The hop that the proxy makes to the other proxy, that's the same hop that was there in the first place. So the only change is really the in-pod hops that go from proxy to service and service to proxy. And that we think is going to be small, like sub-millisecond if you have, it depends obviously on load. But the question you got to ask is the latency cost, which is real, worth the benefits that you get? And we think it is.
Okay, so is the takeaway from this then that if there's a mobile client, then use API management?
Almost always, yeah. That's
right.
Almost always the case. Now, if you have mobile clients, that's not the only reason to use API management. But mobile clients in particular introduce factors that you're going to want API management to kind of handle. The perimeter security that is required for mobile clients, it's beyond just TLS enforcement or JWT verification. You might want to do things like malicious content filtering or XML bomb detection or adaptive rate limiting or traffic pattern analysis and maybe even token binding, where if you get an OAuth token, you can bind it to a particular TLS cert. So lots of things on the perimeter. API management makes a lot of sense for that.
Perfect. So then what I'm hearing is any external client uses API management.
Yeah, probably. If you have external clients, that means traffic is coming from outside. Those clients are going to be outside of your control. So even if it's a client that, let's say, you built as a company, and you're giving it to consumers, it's running on consumer mobile apps, as soon as you do that, there's going to be a hacker, there's going to be a bunch of hackers that kind of decompile that thing and figure out what's going on and figure out reverse engineer the API. So they're going to be sending in APIs that look just like bona fide APIs, which is why you want that perimeter security. So almost always.
Okay. But does API management make sense if all my clients are internal?
So if they're all internal, probably not. But I think that scenario that you just raised seems to be unlikely. So the trend is towards more and more connection, more and more clients. Any entity, any company, any organization that is digitally isolated is not going to thrive. So there's got to be some desire to have inbound communications. Now, a project may be serving only internal clients, and in that case, yeah, you probably don't need API management for that. But when you have external clients, it sure makes sense. And
before I get to my next question, one of the things I like to say with that is that your internal API today is your external API tomorrow.
Yeah.
You just don't realize it, and I've seen that over and over again with customers.
Yeah, a company builds an API, it gets a lot of use, and some product manager or executive says, you know what, we should extend that to this partner over here. It is now external. So you're going to rapidly need API management there.
Right. So my next question is kind of like, don't I get API management with service mesh infrastructure?
Yes, you get some of the features of API management in the service mesh infrastructure. So you get authentication, you get the TLS capability, you get observation, access control. But as we said, in particular in the things that you showed, you want to self-service enable developers to go figure out what APIs are available, get credentials, and embed those credentials into their apps. It's not always going to be an API key. It might be a different set of credentials. It might be a public-private key pair that you're issuing as credentials. But you want to have that be self-service. You don't want to have people emailing around saying, hey, I need credentials, and here, we're going to send it an email. That's not secure. That's not the way to do it. You also need a different set of reporting monitoring for APIs that are being used by external clients, shared APIs. Business people are going to want to see what's the trend in the number of developers that are using my APIs, the number of different partners, or for errors, is there a particular developer that has built APIs that is causing more errors? Different kinds of monitoring and reporting is enabled by an API management platform. That's probably not something you want on the internal APIs. So you do get some API management capability in service mesh infrastructure, but it's probably not enough when you start to share out.
Okay, so there's some overlap there. So I'm going to go back to latency. Again, my consumers are super demanding. Don't I get latency incurred with API management?
Latency-free zone.
Yes.
Wow. Magic.
I'm impressed.
Yes. No, so there is obviously a latency. Every time you add an additional hop, there's a latency. And what we showed in the demo, what you showed was a cloud-based API management gateway. So it was running somewhere on an external endpoint, accessible to the internet.
Magic.
anything that was calling in had to go through the public network, get into that gateway, and then into the internal mesh.
Yep.
Or the services in the mesh. So, yep, if you have an internal client and it's doing that, it's going out the public network, coming in through that gateway, and there's going to be a hop there. So, yes, there can be, but not necessarily. So, at this conference, as you know, we've announced the beta availability of the Apigee Hybrid Gateway, which is the same gateway that we just saw you demonstrating.
Okay.
Same capabilities, but it is able to run inside the Kubernetes cluster. So it's not a sidecar, it's not running right next to the service, it's still a shared gateway, but it's in the cluster, which means it's on the local network, it's going to be fast, it's going to be low latency, and you're going to be able to stay on the private network. So if you have sensitive traffic, there's no regulatory issue there as well.
That's cool.
Yeah, really nice. So yes, there's some latency. Again, go with a cost-benefit analysis, and there's a mitigation where you can run that gateway inside the Kubernetes cluster.
So I think we may have covered this, but do all of the API requests hop out onto the public network?
I think maybe we covered this. So the answer is not necessarily. If you use the Apigee SaaS service today, it's going to happen, but if you run that gateway inside, then you don't.
What about, is Istio required?
So Istio is something that you used, and it does, I kind of broke it down, did a quick overview of what it does. It's not actually required in order to manage services. You can manage services. Different companies use different things. They may use kind of their own approach. They may use HA proxy. They may use Nginx and couple that with some log aggregation tools and call that their services mesh. There's nothing wrong with doing that. And in fact, if a company's large enough, there's going to be heterogeneity in the approaches that they've taken. So it's not absolutely required that you do Istio. We think Istio is a good idea. Mm-hmm. It's being built to address, the 80% case at least for most people. So we think it's worth looking at, but it's not absolutely required. You can still do services mesh with your own tool set and compose that with API management according to the patterns that we just described. That still is going to work great.
Kind of, I think this is maybe my last question, but this sounds like super complicated. Do I really need all of this stuff?
Nope, you don't need it. If you don't want to conduct business, you don't need any of this stuff.
All right, awesome. There we go. And on that.
No, but look, as soon as you have multiple services, you're going to want the capabilities of a service mesh infrastructure. You're going to want that. You want to protect the transmissions between them, and that's the best way to do it. As soon as you start sharing APIs, you're going to want API management software. Now, if you're a startup, sure. Be thoughtful about the things, the components, the tools that you embed into your architecture. You don't want to build the world at first. Maybe you're on this MVP approach. Okay, I get it. Maybe you can economize, minimize, kind of do it yourself on different things. If you're an enterprise, you're a big company, you have governance requirements, you got regulatory requirements, you need tools, infrastructure to help you govern and manage and control those sorts of things, and you're probably going to need both of these in the right doses now. So this is how we think they compose, and this is probably a good recommendation for most big companies. It's not about having cool tools and cool infrastructure.
But I like cool tools.
Yeah, I know you do. It's about getting things done more quickly. Composing service mesh infrastructure and API management allows the business to innovate more quickly, and that's what we're talking about here.
Awesome.
So with that kind of back and forth dialogue, Greg and I tried to summarize the decision criteria for when you want to use more or less API management. I think the call on services management is really simple. If you have more than just a handful of services, you're going to want some service mesh infrastructure. You're going to want something like Istio, at least Envoy or some other proxy, and you're probably going to want a control plane as well. Istio is worth looking at. But for API management, it's a little more nuanced. Where you apply it is maybe interesting. As we said, big enterprises are probably going to be using it, but the question is where, at what layer, at what interface, and these are some of the decision criteria, kind of summarizing what we just talked about.